Hi, everyone. This is Keith from the Developing Mathematical Thinking Institute, and today we're going to talk about area, perimeter, and volume. So yes, we did list those in a specific order for a reason we'll get to here in a moment. And I really wanted to talk about these three ideas with you today because I know when I was in the classroom teaching 8th graders, they really struggled with these ideas. They'd mix the formulas up, they'd label their answers incorrectly. And now working with DMTI, I've learned a lot of ideas that would have helped my students back then. So I want to share some of those ideas with you today. One of the main ideas on area, perimeter, and volume is to really focus on the different units that we use to measure different attributes. So for example, on this slide, we have figure L, figure M, figure N. Need to be very upfront with students and have the discussion. There's something the same about all three of those figures. There's something very different about all three of those figures. So all three of those figures do have a quantity or a measurement of 3. But something very different about those figures is the unit that's being used to accumulate those 3 units. So for example, in figure L, we have linear units. In figure M, we have square units to measure area. And then in figure N, we have cubic units, which is eventually going to measure the attribute of volume. So I'm going to show you a couple different activities that are in our DMTI modules in about grades 3 through 5 that works on these ideas. So we actually begin with area with 3rd graders because they've probably already worked on the area model for multiplication. So we like to connect to that now as we're getting into more of a measurement unit on area. So we're going to look at a rectangle with all of these different square units, have to have the conversation that area is really this attribute, meaning that we're covering a flat space. So that's the specific attribute we're going to look at. And then we're going to choose these square units to measure it. And we want kids to explore a little bit how many square units are covering that space. And we really want to look here, how many kids are just counting them one at a time, all the way from 1 to 42? How many of them are maybe looking at a row of 7 and iterating that 6 times? How many are looking at a column of 6 and iterating it 7 times? So if kids are really just counting these one at a time, they're really going to struggle with our area formulas because they're not seeing that we're really now what the research calls having a composite unit that's being iterated. So we want to press students conceptually, for example, to look at the area of a rectangle like this as 7 iterations of the unit of 6. So if we're going to look at the unit of 6 as that column, that unit of 6 now gets iterated across 7 times to compose my 42 square units in that rectangle. Yes, we have the commutative property. We can absolutely look at that as 6 iterations of the unit of 7. If we look at a row of 7, we do find to really help communication in the classroom, it helps to be consistent on which way you decide to talk about those ideas. And our materials give an example that then we try to stick with all the way through. Then yes, we do need to switch gears a little bit into the different attribute of one dimension. So we want to be very upfront with kids. Let's look at the same figure we've been practicing on for finding area, and that has the 42 square units. But now where can we find some of those other attributes that we could measure in this figure in the first dimension? That we could measure with something like string. So we want to press students conceptually to recognizing that we can measure attributes of the length and the width of the figure. And then that leads to our idea or our measurement idea of perimeter, of the length surrounding a shape or a figure. For kids that maybe struggle with this, something I've done before is we talk about maybe we're going to pretend that there's an ant on our rectangle, maybe up in this corner, and that ant's going to walk around the exterior edge, the outer edge of our rectangle and go all the way around it. How far is that ant going to walk? Which leads into our perimeter formulas, which are now different than our area ideas because they're measuring a different attribute. It always comes back to the attribute and the unit that we're using. We find that it helps kids immensely to actually work with some rectangles that all have the same area. In this example, they all have an area of 16, but now let's find all of their perimeters. So kids can start seeing that, oh, not every rectangle with an area of 16 has a perimeter of sometimes 16 also, in the case of the square over here. So just really trying to work on, if we keep area the same, what happens to the perimeters? Likewise, we love activities with kids. Let's keep the perimeter fixed. So how many different rectangles can we compose out of 24 toothpicks, if those toothpicks are our outer edges? Now we're fixing the perimeter. We're going to compose some different rectangles that all have a perimeter of 24, but they have some different areas to have those same types of conversations. Then yes, we're going to move into volume, where volume now measures a different attribute. We're now going to measure how much three-dimensional space fills an object. So now we're going to use cubic units, because back like in area, we use square units, so it could fill two-dimensional space with no gaps or overlaps. So now we're going to use cubic units with volume because it can fill three-dimensional space with no gaps or overlaps. Now, when we give kids, for example, this rectangular prism built out of 12 cubic units, need to be very upfront with them also that when we're looking at that three-dimensional object, there are still lengths and areas. There's still those attributes that we can find on this figure. But now we want to start pushing kids conceptually into, let's start now finding the volume, how much three-dimensional space fills an object like this. And instead of rushing to the formula, of course, we want kids to look at this conceptually. So for example, we could look at the bottom layer of this rectangular prism, think about how many cubic units compose that bottom layer, and then iterate it up. We could look at the front. How many cubic units compose that front? So we've decomposed that rectangular prism into some different pieces here. And now we're going to take that front and iterate it back. We can do the same with an end. How many cubic units compose an end? And now we're going to iterate it across to the side to figure out how many total cubic units compose that figure. So perimeter, area, volume, it always comes back to the units and the attributes we're measuring. That's just the hugely important key as we're working on perimeter, area, and volume. Keep that in mind as you're working with kiddos on this measurement topic. Hope that was a little helpful. Thanks for joining us today, and we look forward to seeing you again. Thanks so much.